Hey everyone, in this video what we're going to do is we're going to figure out what the limit is as x approaches 0 of tangent of x minus sine of x divided by x cubed. Now if we were to just let x go to 0, in the numerator we would have tangent of 0 minus sine of 0, which is just equal to 0 minus 0, which is of course 0. And in the denominator we would have 0 cubed, which is also just equal to 0. So we have a limit of the form 0 over 0, and in order to evaluate it, we're going to use something called L'Hopital's rule. L'Hopital's rule basically says that if you have a limit as x approaches some value c of a function f of x divided by another function g of x, then this limit is equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x, given that f and g are both differentiable at c and that they're of indeterminate form 0 over 0 or plus or minus infinity over plus or minus infinity. That criteria is satisfied for our problem right here, so we can apply L'Hopital's rule to it. And I should have also said that you can apply L'Hopital's rule indefinitely as long as the criteria which I've just mentioned is satisfied. So we have the limit as x approaches 0. Now the derivative of tangent of x is just secant squared of x, and the derivative of sine of x is just cosine of x. And this is divided by the derivative of x cubed, which is just 3x squared. Now notice what happens if we just let x tend to 0. In the numerator we have secant squared of 0 minus cosine of 0. If you're unsure what this is, just remember that secant squared of 0 is equal to 1 over cosine squared of 0. And cosine of 0 is just 1, so 1 over 1 squared is just 1. And like I just said, cosine of 0 is 1, so we have 1 minus 1, and that's equal to 0. And in the denominator we have 3x squared, so 3 multiplied by 0 squared is just 0. So we actually have a limit of indeterminate form 0 over 0 again, so we're going to have to apply L'Hopital's rule for a second time in order to proceed with this problem. Now, we have the limit as x approaches 0. We can find the derivative of secant squared of x using the chain rule. So we have 2 multiplied by secant of x multiplied by the derivative of secant of x, which is just secant of x times tangent of x. And the derivative of cosine of x is minus sine of x. So we would have minus sine of x. So we just have plus sine of x. And in the denominator we just have 6x. We can tidy this up a little bit. We have the limit as x approaches 0 of 2 times secant squared of x times tangent of x plus sine of x divided by 6x. Now if we were to just let x tend to 0, this term here would go to 0 because tangent of 0 is 0 and anything multiplied by 0 is also 0. And we already know that sine of 0 is equal to 0, so in the numerator we would have 0, and of course 6 times 0 is also 0, so we would have 0 in the denominator. So we actually have an indeterminate form of 0 over 0, so in order to solve it we're going to have to apply L'Hopital's rule again. Doing so we have the limit as x approaches 0. Now in order to take the derivative of the first part of the numerator we're going to have to use the product rule. So we're going to have 4 times secant of x multiplied by secant of x times tangent of x multiplied by tangent of x plus 2 times secant squared of x times secant squared of x plus cosine of x divided by 6. Now notice if we just let x tend to 0, anything that has tangent in it just goes to 0 because tangent of 0 is 0. So this whole term here goes to 0. Secant of 0 is just equal to 1. So this term here goes to 2. Cosine of 0 is equal to 1, so we just have 1 here. Thus we're left with 2 plus 1 divided by 6, which is equal to 1 over 2. And that is the final answer to this problem. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe, as it really does help the channel out. I hope you have a great day.